Hi, my name is Johnny Hancock from Agilent Technologies. I'm an engineer working at the Design Validation Division in Colorado Springs. This is where we design and market digitizing oscilloscopes. In this short video today, we're going to show some side-by-side comparisons of oscilloscope measurements using deep memory. Now, deep memory in scopes is very important today because they're very complex signals, and often you need deep memory in order to get high sample density or high sample rate, and also it helps with the display quality. Now, in today's demonstration, we're going to be showing the advantage of Agilent's MegaZoom technology compared to conventional oscilloscope deep memory technology. For this demonstration, we will show a side-by-side measurement comparison using two 1 GHz bandwidth oscilloscopes. The Agilent MSO6104A, which has up to 8 megabytes of acquisition memory, and the Tektronix DPO4104, which has up to 10 megabytes of acquisition memory on each channel. Let's begin by viewing a common video signal using each scope's default memory. With Agilent's MegaZoom technology, memory depth is automatically maximized as well as sample rate based on the scope's time-based setting. You don't have to select the memory depth. Even with deep memory automatically selected, the scope's waveform update rate is very responsive, as you see here, and the display quality is quite clear, as we can display up to 256 levels of intensity. And if we stop the oscilloscope's acquisition and zoom in, you can see that we have very clear resolution on details of the waveform provided by MegaZoom technology. Let's press run again, and let's select a measurement. Here's a peak-to-peak measurement we're making, and again, still we have very responsive display running deep memory. Let's now perform the same measurement on Tektronix DPO4000 series scope. Here on the Tektronix scope, which has a default memory depth selection of just 10K points, we see a much different picture on the DPO4000. Display quality is relatively poor, although update rate is pretty decent with just 10K of memory. But let's stop the acquisitions and zoom in like we did on the Agilent scope. And you can see, because of the shallow memory selection that was automatically selected, the scope is extremely undersampled and we can't see details of the waveform. What we need is deeper memory. So let's select a deeper memory selection. Away from the default 10K, let's select the maximum, 10 megapoints. Now we have a much better picture. Let's turn the intensity up a bit. It's not quite as responsive as it used to be with 10K of memory. That's why they automatically reduce the memory by default. Let's select a volts peak-to-peak measurement now. Now the update rate drops to just 1 or maybe 2 updates per second, or maybe 1 every couple of seconds. And now you have a very unresponsive display. This is conventional deep memory. Let's now make another measurement where the appropriate memory selection is important. Here on the Agilent scope, we're showing a digital signal that generates a very infrequent glitch. This particular glitch occurs approximately 1 time every 40,000 cycles of this digital signal. Since the oscilloscope can update up to 100,000 real-time waveforms per second, we can capture this glitch approximately 2 times per second. We can also select the infinite persistence mode and capture it permanently once it captures it. Let's now make the same measurement of this glitch on the Tek scope. With the Tek scope's memory depth set up the way we left it with the video signal, which was with 10 megabytes of memory, which we needed for that particular measurement, now we have it set up to capture the glitch. However, with this memory depth selection, the waveform update rate is too infrequent to reliably capture this glitch. The update rate is only a few times per second. This glitch is only occurring 1 time every 40,000 cycles of the pulse. That means we may be sitting here for hours waiting to capture this glitch. So, since we know we really don't need deep memory for this particular measurement, let's turn the memory back down to the default setting, which is 10K points. Now the update rate improves to approximately 3,000 waveforms per second, and statistically we should capture this glitch approximately once every 15 seconds. Now we can turn on the infinite persistence display mode, and once it does happen, we'll have it stored on screen permanently. But the problem is you may be probing around trying to see if your signals look normal, and you may totally miss this particular glitch. There we captured one displayed very faintly. As you've seen in this brief comparison, when considering deep memory measurements, there's more to consider than just banner specs. MegaZoom technology provides automatic selection of deep memory when you need it, provides maximized waveform update rate, maximized sample rate, and maximized display quality. You don't have to think and be a scope expert to know what memory depth to select.